In this video, we're going to look at how to import an MIF file to QGIS to represent line data. For this, start by creating a new project, a base map layer, and yeah, suppose we could start by editing the CRS zone. Click on GTA 94 MGA zone 55, which is Australia's. Click OK, and while we wait for that to load, we can drop in the MIF file containing segment data, which basically was the analysis that we did in a previous video using depth map X. So here's an error which is pointing out at the CRS values not matching up. I'm gonna double click on this layer and change the CRS value first from non-earth to what we have as projects and apply. Now I'm going to click on zoom to layer so that we can see what's happening. Yeah, there we go. Right now it's showing us just the lines. To understand what data it consists of, we're clicking on the attributes table. I can close this, by the way. Yeah. So it's got a fair amount of data. It's got angular connectivity data and axial line references, connectivity, segment length, and the choices, basically the segment analysis of different radiuses. So we're going to start with 150 and maybe even segment length. So to start off with doing that, we go into the properties of, let me just center this first. Yeah, we go into properties and we get into the symbology, select graduated. And now we have to select the value for which it will segregate the values. So I'm going to select segment length. It shows you the longest segments to the shortest ones using color. That's right. And yeah, I'll probably give it yeah, that would be cool. So what we do is once we have selected the value, we either we got to select the mode. So it could be equal intervals or equal count, depending on how the data is distributed across the table. So we could go with equal count. We could go with equal count if the data has a one-sided approach, where like the first half of the table has more values than the second half. So we're going to just like try this out first to see the output. So once we click on classify, it's going to take all of that data under segment length and classify it according to equal count. And there are 5 classes here, so we get 5 colors. I'm going to click on apply to see the output, and the output is as expected. We are able to see the areas on the map which have the highest connectivity. I'm sorry, the areas on the map with the shortest to the longest road length, the segment map. We could actually like tweak this by changing the mode to equal count, and that gives us better control over the range of colors. Yeah. or not. Sometimes it doesn't work. So for this case, it just shows us that the equal count category works. Yeah, that's just about it. There's a small one. And suppose we want to take another aspect of things, such as we're looking at 500-meter choice. We got to classify it again using the same setting. So change the values when you classify. And now when I'm going to click apply, it shows you all of the data that to actually make the data more visible, we can maybe change the base map colors, bring the brightness down, contrast, my lightness apply. So there we go. That will help. So you can see here that whatever's in blue is the least connected in this case because of the 500-meter radius. Whatever's in red is the most connected, and the reds form chunks every here and there, showing that those are points of equal or higher connectivity than the rest of the areas around there. So we can change this to 150 and we'll start seeing smaller chunks of data. Just, I have to classify that again. Yeah, so this shows you the opposite of what we saw previously. Blues being the most connected, which are in, so it creates for these smaller neighborhoods with the highest connectivity. So if a person were to live on one of these blue roads, it means that he's living next to the most walkable streets, the most connected walkable streets compared to the ones on the reds. So yeah, that's the depth map analysis and some of its implications. Thank you.